Hello, my name is Serena Wen, and I'll be presenting an intelligent and data-driven mobile platform for youth volunteer management using machine learning and data analytics. So I am a Key Club officer. Key Club is a student-led volunteering organization, and it provides opportunities for students to make a positive impact on their community through volunteering. The problem is that we have an inefficient event display and sign up system. In the past, at each Key Club meeting, there'd be upcoming events you could sign up for by putting your name down on a sheet of paper. However, our meetings were held in a classroom with over 70 members crowded together, and you can imagine how much of a hassle it would be to jostle your way to a single paper just to sign up. We sometimes use the Remind messaging app, which was meant for mass communication with members to tell everyone about events. Unfortunately, the multiple channels and multiple messaging channels made it confusing to figure out what all the current upcoming volunteering opportunities were or where to sign up. This discouraged lots of event signups. Members missed meetings and weren't able to sign up, and then they didn't have easy access to their volunteering opportunities, and it resulted in events lacking the volunteers they needed. So I present a new approach for the Key Club volunteer opportunity sign-up system. My goal is to streamline the process of signing up for a volunteering event using an application where once members have signed up for an account, they can easily view volunteering opportunity details and sign up for the upcoming events. All event information and sign up will be in one place, and this can be used in the future by various other volunteering organizations and clubs. The main features of this application currently are that users can log in and sign up for a personal account. They can view all opportunities in one place. They can view specific event details and also invite other members to join same events. There is also an administrative role for Key Club officers and for future organizations, their leaders, whoever is managing the events, and they can add new volunteering opportunities. They can also edit and delete events. The LC Key Club application provides an efficient system of updating, viewing, and signing up. Its main features are the home page, which is seen right here, the event details page, and the invite and pending events page, and also additional add and edit event pages for those accounts with the administrative role. When users first download the app, all they need to do is create an account, and by simply just inputting some personal information and username and passcode, then once logged in or signed up, they can immediately view all upcoming volunteering opportunities on the home page. And from there, they'll see the main details, and additionally, the number of volunteer spots filled is also shown. From the home page, users can easily navigate to the specific opportunity in the details page. On the details page, more information is displayed, specifically like the event details and which other volunteers are signed up. They can also from there invite other Key Club members. If a user has been invited to a volunteering event, a notifying icon will show up on the Invites tab on their bottom navigation bar, and that is where Key Club members can view the volunteering opportunities they have been invited along with who has invited them. They can choose to accept or ignore the invite, and if they do, then the event will be removed from their page. One final significant component that I mentioned earlier was the admin role, and this includes the edit and delete ability. And this is just an overall diagram of the screens of my program. The development tools I used Flutter for the UI software. It's a UI software development kit created by Google, and I used it for the user interface design along with the Dart programming language. The database, I use the Firebase database to store information for events, user info, all that things. And then a configuration management database class, a CMDB class, was used for easy data communication with the database. Going into the actual features and the looks of the app, Here is the home page. This is one of the main features. It's where all upcoming events are listed, and along with the events that the user has signed up for. All necessary details are shown, like the main details, the name of the event, the number of spots left. So if there are no spots left, it will show full, and also the time and date. These are the most important ones, information for users to just see when they just want to glance at the page. The most important code of the homepage component was the retrieval and organization of volunteering events from the the organization of volunteering events data from the events database. So this get all events method immediately sorts and filters the events into only the ones that are currently upcoming. So past events will not show up in the all events section. Once the data is retrieved, it first then loops through each of them, the date attributes, which is the filtering part, to ensure that only events that have not occurred yet appear on each user's homepage. From there, the events are stored into a map, and it's later iterated through in a list builder user interface function to display on the application screen. Here, there is also the sort events part, where it sorts the events in order of which is the most upcoming. So back here, you can see that these are all sorted in order of date. So the October event shows up first, and then it goes December events. There was also a challenge of the homepage UI was regarding the collapsible function. So these boxes can be collapsed. So you don't want, say if there's a lot of all events and you only want to see your events. But regarding this function, I encountered challenges with keeping the boxes collapsed. So say if a user wanted to keep the boxes collapsed, just they closed both of them, it would not stay collapsed if they exited out of the app and came back. So to solve this issue, I used the shared preferences object. So now whenever a user switches away from the homepage tab or back, the collapsed or uncollapsed states of the my events and all events would be saved and maintained. This is the code for that function specifically. So each time the homepage is clicked on, then it'll check if it'll check the user preferences for collapsed or uncollapsed. A next important part of the app is the event details page. So once a user is interested in signing up, they will click on the event and they will be brought to this page. Here, there's much more detailed information, including the location of the event and any important details needed to know. So for example, for leaf raking, the users who are signing up might need to know they need to bring warm clothes or bring tools or rakes. And then they can also view which members are signed up, which is useful. Say if you see another friend signed up, you might want to also sign up. And another feature is the website sign up link, which is right here. So in some cases, for some events, there might be an outside link to sign up. And so with this link to a website, then it'll, with this link to the website, users can easily access it from the event details page rather than having to go out of their way to search it up or put the hyperlink into their, search the hyperlink up themselves. And then there is also the invite pages. So once a user has signed up, they have the ability to invite their friends. And then here it lists out all the users who are not yet signed up. And you can choose to invite them. And once it's invited, it shows the box turns gray and shows that you're invited. And then for users who have been invited, on their screen, they get a notification that pops up on one of their invites tabs. So this user has 3 invites. And you can see there's 3 events here, and they can also view which other people, who else has invited them. They can choose to ignore it or accept it. And the code for this place. So the most important code for the invite friends page is the filters for only showing members who are not yet signed up for the app, and a search function, which also requires another filter. So the this is filtered through by checking it with the database if the user is not yet signed up. And then the search function requires a second list that shows filtered names versus names. There are also administrative features, like I mentioned before. These ones include the ability to create a new event, to edit an event in case there's a time change or details you want to change the volunteer limit. All of that is allowed to be edited for people with the administration function. So those were the main features of my application, and the main challenges I encountered with this application were, first of all, deciding the logistics of the application's features. So in the beginning, I knew what I wanted the app to do in general, to be able to provide an easy place for volunteers, for members to access volunteer events. The first challenge was figuring out the specific logistics of these features so I could code them, such as the invite other members feature. At first, the initial idea was that members would be able to search up what other members were there and invite them to an event. But as I delved further into coding, I realized there were some important questions, like would I have a friend system, like how other social media apps have the friend system where you have to only invite your friends. And so my question was, would I have to implement a friend system? And I had to consider the complexity of solutions. As like if I were to implement a friend system, it would take extensive coding and more time. So eventually, after discussing with other Key Club officers, we came up with a simpler solution to the invite feature, which I showed, where users could invite any other members to an event, and those who got invited would be able to view who invited them. Other questions regarding logistics that still need to be considered in the future involve, for example, reusing the app for future subsequent years. Say if each year the roster of members changes each year, and that is part of my plan for the future. A second challenge was designing the user interface. This one was particularly hard because I first had to become familiar with the Dart programming language and the Flutter development kit and understand how various objects I used could make the screens look like how I wanted. For example, the challenge with the homepage was the collapsible boxes. And there was also a lot of debugging that went into this user interface code. For example, for designing the bottom navigation bar, which was the icons at the bottom for home, invite, and profile. For the users under the role of admin, have an additional icon in there about a navigation bar for adding an event. And so I had to debug some issues with the navigation bar looking different. And UI design was very important because it has to be user-friendly to make it so those who download the application will actually want to use it. The third challenge I encountered was connecting the app to the backend database. So after developing the UI, I had to connect the Firebase database to be able to communicate with the app itself, because there was a lot of important information, for example, updating events, creating events, new users being created, users signing up for events. So I had to make sure the app was functioning correctly here. For the two main sections in the database are the user data and events data, and they're very interconnected. For instance, whenever a user signs up for an event, the event has to be added to the user data and events data, and they both have to be updated. And I encountered lots of like null pointer errors when you try to retrieve data that wasn't there, and I had to be able to figure that out. Finally, for the experiment and evaluation, overall, the purpose, my future plan for this app is to include the event recommendation system based on users' interest. So certain event types will be recommended to a user based off of the different attributes. There was four experiments I went through, and the goal was to determine which machine learning models to use out of four models. So the four models I looked at were the support vector machine, SVM, random forest classifier, RFC, Gaussian naive Bayes, and the stochastic gradient descent classification. The four attributes I looked at were gender, grade, main interest / hobby, and personal availability. So the goal was with this to figure out which, there was different questions about how I should use these attributes and how I should use the models to help create an accurate recommendation system. With the first experiment, the question was, which machine learning algorithm provides the highest learning accuracy? Answering this question of the experiment was necessary to decide which machine learning algorithm was best to use. I first tested each model with the dummy dataset size of 1,000, and then the datasets were divided into training and testing data with which the models were fitted and tested. The score was then calculated for each model's accuracy, and I gathered the average score data from 20 trials of dummy data. The graph below compares, the graph here compares the average accuracy score for each model. The dummy data is basically, I just randomized, it was biased randomized data that was generated. So here you can see that the Gaussian naive Bayes classification model had the highest learning score here. So therefore, for the development of the recommendation engine in the future, I will be using this one. The second experiment was, how does the size of the data set affect the accuracy? The purpose of answering this experiment question was to further understand the factors that led to the highest accuracy in training and testing the machine learning models. In this case, I studied how the factors of dataset size affected accuracy. I varied the dataset size with values ranging from 50 to 1,000 and then tested it for each of the algorithms. This one is specifically for the GNB model, since I plan to be using that for the recommendation system. I went to the same process of generating dummy input and output data and then training and testing it. And I recorded an average accuracy score for 20 trials. For the GNB model, the highest accuracy was produced with 1,000 size. And for other models, like the SVM, it was also 1,000. With the SGDC, surprisingly, it was the size of 150. And for RFC, it was the size of 150 also. Since the GNB is the one I will be using, the planned dataset size will be 1,000. The third experiment was questioning which attribute input combinations would provide the highest accuracy. To test this question, I used 6 different combinations. One was all 4 attributes. 4 of them included just a mix of 3, and then the final one was simply the interest attribute. I utilized the Gaussian NB model since it had produced the highest overall learning score in the previous experiments, and I used a dataset size of 1,000. The final results showed there wasn't too much of a difference between each combination, but the combination of all 4 of them produced the highest accuracy. This follows along with the logic I did with the partially randomly generated code for the output data, the biased randomization, because I made it so the main interest held the most weight. So that's why the interest here has a pretty high score. This is significant because it shows that the machine learning algorithm GNB was able to recognize that pattern. In conclusion, for the experiment, I'll be using the Gaussian naive Bayes machine learning model, since it would produce the highest accuracy for the future development of the recommendation engine. And the model will be used with dataset sizes of 1,000, and inputs would include all 4 of the attributes, which are gender, grade, interest, and availability. In this paper, I propose a solution designed to address the barriers of taking part in volunteering opportunities provided at my school's Key Club. A mobile application I developed provides members easy access to the details and sign up areas of all upcoming events. And officers can also conveniently add and edit the current volunteering events that appear. The application will also, in future updates, be able to further encourage volunteer signups by recommending relevant events to users based on their profile. In my experimental research, I studied the accuracy of specific machine learning algorithms in developing this recommendation engine, focusing on which combination of factors would produce the highest learning accuracy in recommending an event. Through this experiment, I discovered that the GNB machine learning model produced the highest accuracy in predicting which volunteering event types a user would prefer. In the future, I plan to incorporate push notifications and reminders into this app, and a wait list for event signup. For example, if an event is full because the volunteering limit is full, but a user still wants to sign up, they can call on the wait list, and in case someone cancels, they will be notified that they can sign up. I also plan to incorporate something that will count volunteering hours, since often many users might want to know how many hours they've been volunteering. And I also plan to improve the user friendliness of the app, such as enhancing the UI design and implementing the recommendation engine as part of my research. This would enhance user experience on the app and further motivate users to continue using them. Finally, I plan to expand the application so it can be used for all types of volunteering organizations or clubs. This will be done by making the app into a template that can be customized, then utilized by different groups to help them coordinate event signups.